Assalamu alaikum. I am Rokia Fabbi from Dhaka. I am studying in BSc program in Department of ECE in Rajshahi University of Engineering and Technology. Today I am going to discuss about perceptron, that is a single layer neural network. A perceptron is an algorithm used for supervised learning of binary classifier. There is given a table which contains x1, x2 input and output y. If we consider second row value, x1 is equals to 0 and x2 is equals to 1. Uh, so, uh, and weighted value w1 is equals to 0.1, w2 is equals to 0.2 and b is equals to 0, then weighted sum will be 0.2. It is go through an activation function such as sigmoid. It will give an output which is close to 0. So output will be 0, but here the expected output is 1. So the error will be 1. Now we'll have to perform back propagation and update weight. Then how we'll update the weight? Weight equation here, updated weight is equals to previous weight minus learning rate into del error by del w. Del error by del w is gradient descent. So del error by del w is equals to error error into output 2 into 1 minus output 2 into input. Here is the equation of output 1 and output 2. So that's how we'll calculate the error, and if the error is very close to 0, then we'll take the result, otherwise we'll perform the same rule. Now I will discuss an example with implementation. Here I have taken NumPy library and input features are 4x2 matrix, and this is input feature, and target output will be 4x1 matrix. Here is weight, that is random value 0.3 and 0.4, and bias is 0.3 and learning rate 0.5. And I have taken sigmoid function and derivative of sigmoid function. Now I'll go directly to the main code. I'll discuss where I have taken 10,000 epochs. And here input is equals to input features, output 1 is equals to weight into input value plus bias, and output 2 will be sigmoid of output 1. And error will be calculated by difference of target output and output 2. Now I'll calculate the error. Here I have transposed the input features matrix for dot product of inputs and derivative. So here I'll get the final derivative output. It is because we have to calculate weight. It is updated weight. So the previous weight minus learning rate into final derivative. So from the weight, and this is the updated bias. So from this I have got this result, and printed weight is equals to 7.01 and bias minus value. And we can see the output weight is more than we have assumed. Now if we predict x1 and x2 is equals to 0, 0 and expected out is equals to 0, then result 1 is equals to multiplication of weight and input plus bias, and result 2 sigmoid of result 1. If we print result 2, then we'll get 0.040. That is very close to 0. So we have got the expected output considering the updated weight. Here we can see the same thing. So we can see that if we consider the updated weight for determining the result, main result, we will get less error, and that's how we'll get the our expected output. So this is neural network. Thank you everyone.